Hi everyone, my name is Rituja and welcome back to Data to Crunch, where we learn more about data engineering and business intelligence. So, in today's video, we will dive into the exciting world of Azure. I'll walk you through the process of creating an end-to-end ETL pipeline in Azure, where we will try to utilize main Azure services like Azure Data Lake Storage, Azure Data Factory, and Azure Databricks. And afterwards, we'll see how we can connect these services to the Power BI so that we can create reports and the dashboards for the same. So basically, we'll start with learning some basic concepts of the same. Then we will see how we can set up these Azure services to create this end-to-end ETL pipeline. And afterwards, we'll see how we can use these tools to clean, transform, and visualize our data efficiently. So for this, I can say that we are going to use Amazon Prime dataset for the analysis purpose. And by the end of this tutorial, you will have the understanding of this ETL pipeline. And along with that, you will have the deeper understanding of how these powerful Azure tools come together seamlessly for the data workflows. So now let's move ahead and learn more about our dataset. Before we start working with the data, let's quickly go over this Amazon Prime movies and the TV shows dataset on which we will be working on. So I have downloaded this dataset from the Kaggle website and I'll provide the link of the same in the description box below. So this dataset contains the information about the titles available on the Amazon Prime, which mainly includes movies and the TV shows. So it has several key features that we can use to analyze maybe trends, ratings, genres, and many more. So now let's see or take a look on our columns which we have. So we have column which gives us unique show ID. Then we have other column which gives us the type of that respective movie or the TV show. Then it also displays the title of that movie. Then it gives the director of that respective show. Afterwards, it also gives us the cast of that respective movie. Afterwards, it is also giving us the country of that production of that respective movie. Then we have date added column, which gives when that movie or TV show was added onto Amazon Prime. Then it also gives the release year of that movie or the show. Then we have ratings column, and after ratings, we have duration of the movie or TV shows column. So this dataset basically offers a lot of interesting possibilities for the analysis by like including exploring relationships between, for example, maybe in between genres or the release years or the ratings, or even like examining the trends in the movies in the movie popularity across the different countries. So what I have done here is like I have downloaded this dataset and I have uploaded it on my GitHub account. I'll provide the link of the same also in the description box below. So we will see our further procedure where we will try to see how we can fetch this data from this GitHub account to our Azure services and then how we can perform our cleaning and transformation activities of the same. So now let's move ahead and let's have an overview about our whole procedure which we will be working on. So this is the overview of our end-to-end ETL pipeline, which we will be creating using Azure. So our source is this GitHub account link where we have stored our dataset, and our destination or the endpoint will be the Power BI where we will try to create some dashboards and the reports on our transformed dataset to represent it in front of the business. So here we are going to use three Azure services. So the first one will be Azure Data Lake Storage Services, which is ADLS, where we will try to store our data. So here also for the storage purpose, we will follow the Medallion architecture. So Medallion architecture is a data management framework which we commonly use in our modern data lake or the data warehouses. So basically here we organize our data into three distinct layers. For that we call it as a medals. So the first medal will be bronze layer or bronze medal, then the second will be silver, and then the third will be gold. So the purpose of bronze layer is we will use this bronze layer to store our raw and unprocessed data which we have ingested. So right now our dataset is into GitHub account, right? So now we need to fetch this dataset into our Azure services and then we need to store that data into our ADLS. So for that purpose, we will use Azure Data Factory. So what Azure Data Factory will do, it will fetch the data from our GitHub account, and then it will store that raw and unprocessed data into our ADLS account. So now, till now, Azure Data Factory has done its purpose. Now, Azure Databricks comes into the scenario. So what Azure Databricks will do? So Azure Databricks will work on this raw and unprocessed data set, and then it will try to clean and transform that data so that our so that it will be easier for the analysis for the data scientist or the business intelligence, whoever the team who is going to work for the further procedures. So right now we have this raw and unprocessed data in the bronze layer, right? So now Azure Databricks will perform data cleaning and data transformation. So it will basically take this data from bronze layer, it will perform its activity, and once they have done that transformation, then they will store that data into the silver layer. So here the second layer comes into the scenario where we have cleaned and transformed data into our ADLS. So the data at this stage we can say that has been processed to handle the inconsistencies or the missing values or the duplicates or to derive some more meaningful relationships between the data set. So till now, after this silver layer, this gold layer comes into the scenario. So this gold layer basically represents the highest level of data refinement, and it is intended for the business intelligence purpose. So at this stage, we can say that our data is fully processed and optimized for the final consumptions. So right now we know that our data has been transformed and stored into the silver layer, right? So now we using Azure Databricks, we will use this data and we will fetch this data from the silver layer, and then we will try to perform some advanced transformations on the same so that we will get that data which is business ready. So once we have that business ready data, then we will store that data into this gold layer. So now what does this mean by business ready data? So business ready data means it is intended basically for the business intelligence and the reporting or the analysis purpose. So till this stage, the data is fully processed and optimized for the final consumption by the business users. So here we can say that our data is highly curated and it is stored in a final reporting friendly format, such as, for example, maybe Delta Lake or the Parquet. So we will store our data into such kind of formats. So once we have data into the gold layer, then what we will do, we will connect our Databricks to the Power BI services. So that what we can do, once this connection is ready, we will fetch this data from the gold layer, which is into Delta or the Parquet format, and then we will pull this data into Power BI. And once we have that data into the Power BI, we will create dashboards or the reports. So this will be our end-to-end ETL pipeline overview. So now let's move ahead and we'll first see the basic concepts which will be required for the understanding of this ETL pipeline. Let's try to understand the ETL process. So for the first step, extract, the main goal of this extraction process is to pull the raw data from source systems without making any changes to it. So the extract phase, it basically involves like gathering of raw data from the various source systems, which could be, for example, databases or the APIs or the flat files or even the live streams. So this data, it could be either structured, semi-structured or unstructured. So after extract, we have transform process. So for the transform, our objective for this step would be to ensure that our data is accurate, consistent, and formatted correctly for the reporting or the analytics. So the transformation phase is where that raw data undergoes the processing or the cleaning to meet the desired structure or the quality and the format of that respective data for the reporting or the analysis. So this phase basically includes data cleaning, aggregations, validations, filtering, or other operations to ensure that we have suitable data for the downstream applications. So after transform, we have load. So the objective of load is to store the transformed data in a format that is optimized for querying or the reporting so that it would make it easier for the access for the users or the applications. So this loading phase is where the transformed data is stored into the final destination. Usually that would be data warehouse or the data lake, and it will be easier for the querying, reporting or the analysis. And this data can be done into either a batch mode or the real-time mode also. So in our case, we'll see how this ETL pipeline will work. So in our case, extract process, this will, in this basically Azure Data Factory, this Azure Data Factory will pull the data from the external sources like GitHub account or maybe Kaggle. It will pull that data and it will store that data into the bronze layer, which we will make it in the ADLS, which is into Azure Data Lake Storage Services. Then into the transformation, this Databricks will come into the scenario, and this Databricks will read the raw data from the bronze layer, then it will perform cleaning and the transformation, and it will make that data into a more structured format, and then it will store it into the silver layer. So once it is stored into the silver layer, it can also perform some additional and advanced aggregations or the refinements. So once those aggregation and refinements are done, then that advanced business intelligence ready data that will get stored into the gold layer, where that data is curated and optimized for the reporting. So into the load process, that transformed data which is into the gold layer, then that that business ready data which is loaded into the which is already into the gold layer, that will get loaded into the Power BI tool. So we will fetch that data which is stored into the gold layer into Power BI. So once that is done, we can create dashboards and reports to represent it in front of the business. So this is how this complete ETL process will work in our case. Now let's try to understand what is Medallion architecture. So the Medallion architecture is a data management framework commonly used in modern data lakes or the data warehouses. So basically it organizes the data into three layers, which is namely bronze layer, silver layer, and the gold layer. So each of these layers or each of these steps are designed to handle the data at the different stages of the processing and the optimization. So in a Medallion architecture, data is progressively refined as it moves from bronze layer, which is nothing but raw layer, to the silver layer, which is cleaned and enriched data layer, and afterwards to the gold layer, which is business ready data layer. So the goal basically here is to ensure that we have scalability, performance, and high quality data at every stages. So the first layer is a bronze layer, which is nothing but a raw layer. This bronze layer is where we have our raw, unprocessed data, which is ingested and stored. So basically, it is also referred as a landing zone or a raw data zone. So if we talk about the characteristics of this bronze layer, then the data is typically stored in its native form. For example, CSV form, JSON form, or Parquet form, any form of any kind of form. So it is directly from the source system, and there are no transformations which are applied at this stage. So we can say that data is stored as it is. So as it is stored as it may contain errors, duplicates, or any missing values. So basically the focus of this bronze layer is to capture and preserve all the incoming data without losing any information. So in our case, we are going to ingest our data from GitHub to this raw into this raw format, and we are going to store it into ADLS. So after this bronze layer, we have silver layer. So the purpose of this silver layer is we need this silver layer where our data is cleaned, transformed, and enriched for the further analysis. So data at this stage has been processed to handle the inconsistencies or the missing values or the duplicates and to derive some more meaningful relationships between the datasets. So if we talk about the characteristics of this silver layer, then we can say that at this stage, data is transformed into more structured, normalized, or enriched form. So for this, it may involve the operations like data cleaning or deduplications or the validation. So it can also include basic business logics like maybe creating some additional columns or data conversion or categorizations. So we can perform these kind of basic logical transformations in this layer. And this layer, the data in this layer is typically suitable for the EDA, which is nothing but exploratory data analysis and intermediate reporting. So, what could be the use case for this silver layer? Then we can say that data scientist or the analyst, they can use this layer to build machine learning models or to conduct some further analysis in Databricks. So basically, it serves as a foundation for the gold layers curated and business ready data. So in our case, we are going to use Databricks for this silver layer, right? So we might clean and transform the raw movie data. In that, maybe we will try to remove some duplicates and we will try to handle some missing values. And we will store this result into this silver layer in the format or in the delta or for packet format. So we will store that data into silver layer into any one of these format. So the next layer is gold layer. So the purpose of this gold layer is that this gold layer represents the highest level of data refinement and it is intended for the business intelligence reporting and the analytics. So we can say that at this stage, the data is fully processed and optimized for the final consumptions for the final consumption by the business users. So what could be the characteristics of this gold layer? So we can say that data is highly curated. So it often includes aggregations or the summaries or the derived matrices that will answer the specific business questions. So this layer we can say that it optimized for performance or the fast querying. So fast querying means using, for example, indexing or partitioning or Z ordering. So such kind of fast querying we can use this gold layer. And lastly, we can say that it is stored in the final reporting friendly format such as Parquet or the Delta Lake. So what could be the use case for this gold layer? So we can say that we can use this for the dashboards, reports, or the KPIs, which will basically help for the decision making. So business teams or the managements, they can use this layer to extract the insights and perform some trend analysis and make some data-driven decisions. So in our case, we can say that for this Power BI comes into the scenario. And after transforming the data, we might need to, for example, aggregate the movie counts by genres or the year, and we need to save this final data set into the gold layer. So this data is now ready to be consumed by the Power BI dashboard for the reporting. So we can pull this data from the gold layer into the Power BI and then we can perform next business driven activities, which are creating reports and the dashboard. So this is how this Medallion architecture works and this is how it will perform in our end-to-end ETL pipeline, which we are going to create now. Now we will try to see what is Microsoft Azure exactly is. So Microsoft Azure is a cloud-based computing platform and the service which is offered by the Microsoft. So it provides a wide range of cloud services, including like computing power or the storage, networking, databases, analytics, artificial intelligence, and many more. So the businesses and the individuals, they can use this Azure to build, deploy, and manage the applications on a global scale without needing to maintain it on the on-premise infrastructures. So why do we need this Azure? So there are some points for that we need Azure. So the first one would be the scalability and flexibility. So Azure basically allows the businesses to scale the resources up or down based on the demand. So with this, they can ensure that they have optimal performance without needing the upfront hardware investment. So to avoid this hardware investment, we can prefer Azure and it will give us the scalability and the flexibility. The next one I would say is cost efficiency because Azure has that pay as you go infrastructure. So because of this pay as you go, organizations will only pay for the resources they are going to use and it will ultimately reduce the operational expenses. Then the third one I'll say is global reach and the availability. So with this, for this, the Azure has data centers across the world. So Azure provides the high availability and it ensures that applications run closer to the end users and it ultimately improves the performance. So after this, I'll say the security and the compliance. So Azure basically offers industry-leading security measures, which includes like multi-layered protection or the encryption or the compliances with global standards like GDPR or HIPAA. So such kind of compliances this Azure offers. So for that also so many companies prefer Azure. And the next one I'll say is integration with the Microsoft and the open source tools. So this is kind of a main thing for which Azure is preferred because Azure works seamlessly with the other Microsoft products also. For example, it would be like Office 365 or the Power BI or the SQL Server, as well as some open source frameworks such as like Python, Spark, or the Kubernetes. So such kind of integrations, these integrations are made easier with the Azure. So that is also one of the one or main major because of which Azure is getting preferred right now. So now we are going to create ETL pipeline, right? So we'll see which Azure services we are going to use right now. So the mainly we'll see the first one is Azure Data Lake Storage Services. So this ADLS is highly scalable. I can say that this ADLS is like secure and the scalable cloud storage service, which is basically designed for the big data and the analytics workload. So why do we need this ADLS? Okay, so it stores the raw or semi-processed or the processed data into the different layers which we have seen earlier via this Medallion architecture, right? So such kind of data gets stored in ADLS. So it basically gives us that storage, and apart from that, it also supports the hierarchical namespace. So it will improve the performance in the file operations. So hierarchical namespace, as in it will allow you to create one folder, and in that it will allow you to create subfolders, and in that you can store the file. So creating these subfolders, it is nothing but creating this hierarchical namespace. So it has this ADLS gives that facility, and it makes us easier for the file operation. And apart from that, it integrates seamlessly with the Azure Databricks and other Azure services also. So right now, Azure Databricks is important because in this ETL pipeline, we are going to integrate this ADLS with this Azure Databricks. So that is why I said Azure Databricks, and there are also other other Azure services also with which it is compatible. And next service I'll say is Azure Data Factory. So this Azure Data Factory is nothing but a cloud-based storage which gives ETL service, which is used for the data movement and the transformation. So if we say like, why do we need this ADF? So we can say that this ADF will ingest the data from various sources. It could be anything like in our case, it is HTTPS, right? So it could be SQL or the other APIs or the cloud storage or on-premise database. It from these such kind of various sources, it will help us to ingest that data into ADLS. And apart from that, I can say that it can also schedule and orchestrate the workflows by automating the data pipeline. So in our case, we are fetching the data from one source, right? And then with this copy activity, we are using here ADF. We are storing the data, we are fetching the data from our source to destination. So we have done that. We have done that using with this manual intervention, right? So, but what if I want to use it without any manual intervention? Then for that we need to schedule and orchestrate this workflow, right? So it will basically also allow automating this data pipeline. So it this ADF has that facility also in the, which is this orchestration and automating. And apart from that, it integrates with the Azure Databricks also for the transformations and Power BI for the visualization. So we are going to see like how we are going to connect this Azure Databricks with the Power BI. So next to that is Azure Databricks. So Azure Databricks is a big data analytics and machine learning platform which is based on Apache Spark, which is optimized for this Azure. So it basically provides high performance distributed computing for the large data sets. And apart from that, it supports the languages like Python or SQL or Scala or R. So such kind of languages it supports for the data processing. And apart from that, we can say that it can process structured as well as unstructured data very efficiently. And apart from that, it integrates seamlessly with ADLS, Azure Data Factory, and other Azure services also. So the next one which we are going to use is Power BI. So Power BI, we all know that it is a business intelligence and data visualization tool, which basically enables the user to create interactive dashboards and the reports. So why do we need it? So we can say that it connects directly with the Azure Databricks or the ADLS for the real-time insights. So it gives a seamless integration. And apart from that, it also supports the direct query and the import mode for the data retrieval. So for this main purpose, we are going to use Power BI. So in our case, the use case would be to connect the gold layer which we have and get fetch the data into Power BI to create the dashboards. And with the creation, we can also visualize this data using KPIs or other trending patterns or business matrices. So it will basically allow you or enable this real-time reporting using this direct query mode, which we are going to see in some time. So these are the components which we are going to use in our ETL pipeline. Now let's try to learn more about management level and the hierarchy. So Azure provides you with the four levels of management. So the first one is management group, followed by the subscription. Then the third one would be resource group, and the last one is the resources. So if we talk about the management group, so it basically helps you to manage the access policy or the compliances for the multiple subscriptions. So all the subscriptions in that particular management group, it automatically inherits the conditions which are applied to that respective management group. So subscription, like what is subscription exactly? So subscription, we can say that it logically associate the user accounts with the resources which they create. So each subscription has limits or the codes on the amount of resources it can create or use. So organizations can use these subscriptions to manage the costs or the resources which are created by that particular user or the team or the project. So basically in the company, what they do that for any respective team or that particular user, they will allocate one subscription so that whatever user will create across that subscription, that will get billed for that subscription. So it will logically associate that user with the resources which they have created. So this is how this subscription level works. Then the next one is resource group. So if we talk about it, then the resource group, we can say that is a logical container where you can deploy and manage the Azure resources like virtual machine, web apps, databases, or the storage accounts. So we can say that it is nothing but a logical folder in which we are going to store all our resources. And resources are nothing but the instance of your services which you can create in that resource group. So in our case, we have these services, right, which is like ADF or the Databricks. There are Synapse also, which we will use into any another project or SQL database or ADLS or like any virtual machine. So these all are nothing but the resources, which are nothing but the instances of the services which you can create. And we basically what do we store all these services into a particular folder. So that folder is nothing but a resource group. So in this resource group, I can say that I have stored this SQL or the ADLS. So that depends on you. So what we'll do, like we'll have subscription. If you have free account, then you will get that subscription for particular dollars for the free, or like if you're using pay as you go, then you will create one new subscription, and in that new subscription then you will create this resource group, and in that resource group you will create all the resources or instances which we are going to use to create our ETL pipeline. So this is how this management level and hierarchy works. So now we will try to implement this management level and the hierarchy in our ETL pipeline, and we'll see how we can create the subscription, then resource group and the resources, and via that or through that we will create our pipeline. So now let's move ahead and see our practical part. Now let's start with our practical part. So for that, just go to the Microsoft Azure portal, and here you will get the option for sign in and get started with the Azure. So if you're a newcomer, just click on get started and with Azure, and then try this Azure for free. So you will get 200 USD dollar, and for that dollars you can use these services for free for a month. So this is one of the good option which you can opt. And otherwise you can go for the pay as you go. So for the services which you will use, for that only you will get billed for that particular subscription. We'll see this is how our Microsoft Azure portal looks like. So these are the Azure services which I have used recently. This is my recent work. On the left hand side, if you click on these three arrows, you will get all the facilities like dashboards, all the services, resource group, SQL DB, databases, virtual machines, and so on. And if you're not getting anything, you can simply search here and you will get that particular service. So the first thing in our management hierarchy was management groups, and after that it was subscriptions. If I'll just say subscriptions, then I'll get that service. Click on that, then you will see like how many subscriptions you have right now with active or disabled status, and you can check like what's the current cost which is right now causing you. So right now we'll see like I don't have any free subscription, so I'm on pay as you go. So I can see that subscription here with my current cost, or if you suppose would like to create a new subscription for the billing purpose, then you just click on add, and with add you can just give whatever the subscription name which you want to give, whatever it is, and then billing account, billing profile. So your credit details you need to enter, so that on that respective card that you will get billed for on that respective card, and you just need to click on create and review and create. So right now I'll just not create any new subscription, I'll use the existing one, but this is how you can create the new subscription. So yes, I would like to discard. So now once you are done with the subscription, then the third step was to create the resource groups. So I would like to create one new resource group. So for that, I'll come here, click on create. So here it is by default selecting the subscription which I have right now. So if you have multiple subscriptions, then just click on this drop down and select whichever subscription you want to. So right now I just have only one, so I'll select that, and then you need to enter the resource group name which you want to give for that respective resource group. So for example, I'll just give Amazon Prime book. You'll see that this is available. Then the regions, we have different regions. So I'll just select the nearby region, for example, Central or the East. Okay, let's just go with the East US. Then click on next. Tags we don't need to. Next. And lastly, it will give you one review and create page where it will show you under this subscription you are going to create this resource group under the region East US, and I'll just click on create. So it says that resource group created. I'll just refresh it once. Okay, now we can see that it has reflected here. So this is my resource group, which is third management level. Now under this resource group, now we are going to create our different Azure services so that it will act as a folder for our different kinds of services. So the first service would be to create our storage account, which is nothing but ADLS account. So for that, what I'll do, I'll just click on create. So it will navigate you to the marketplace. So here I need to search for storage account. So this storage account we need to select, click on create. So if you can see that respective subscription and resource group, it has been allocated by default. So for example, like if you want to create a new resource group, so you can just click new and you can assign a new resource group. And once you will click on OK, that respective new resource group will also get created in the backend. But right now what we have done, we have first created our resource group, and in that resource group, we are going to create our other storage services. So it has selected by default that RG Prime work. If you would like to switch amongst the other existing resource groups, you can do that. So right now our resource group is RG Prime work. Then you need to give a storage account name. So for that, suppose for example, I'll give ADLS. Okay, so it is giving me error as like it can contain only lowercase letters. So ADLS Prime work. Okay, now it's checking and it shows that it is available. So region, I'll just keep the near one, East US. Then we have primary service option. So in that, our primary service would be Azure Data Lake Storage, where we are going to store our data into 3 layers. So I'll select that primary service. And then we have this option as performance option. So in this performance option, we have this standard and premium. These two options are available here. So we can say that with this standard performance, right? So this one is like mainly suitable for the general purpose storage needs, such as like storing large amount of data that is frequently accessed, or like which we are going to store somewhere. So for that, we can use this standard performance. But if we talk about the cost, so like it's better than the premium, and this standard, it is more cost effective, and it is basically suitable for a budget cautious scenarios where like high performance is needed and there are not any kind of critical requirements. So if we talk about about the costing from the costing purpose, then I'll say we should go with the standard one. So with the premium, we can say that premium is basically designed for the high performance, basically for the high performance workloads that demand low latency and the high transaction rates, such as, for example, for the virtual machine disks or the any transactional databases or any big data systems. So for that, premium performance tier is very much good. And in terms of cost, it generally costs higher than the standard tier, which reflects the superior performance capabilities. But right now our work is not that much heavy, so we'll just opt for the standard option. And if we now talk about the redundancies, then we have four types of redundancies. Now let's quickly see how these all four redundant storage services works. Now let's talk about the Azure Storage redundancy offerings. So Azure Storage offers like various redundancy options, basically to ensure that your data remains available and durable, and even in the face of like hardware failures or power outages or any natural disasters, we need our data intact. So for that purpose, Azure offers this redundancy offerings. So these redundancy strategies basically reflects your data across the different locations by providing the protection against your data loss and ensuring that business continuity gets maintained. So this is the main purpose of this redundancy offerings. So the key purposes of this storage redundancy would be like first would be data protection, because redundancy safeguards your data from unexpected events, such as for example hardware malfunctions or the data center outages. So it basically protects you with these such kind of outages, and it maintains the multiple copies across the various locations. So data protection is the main key feature for this or key purpose for this redundancy offering. Then the next one would be Azure, this high availability. So by replicating this data, this redundancy ensures that your applications can access the data with minimal downtime even during the disruptions. So high availability is the second most important factor. Then the third one we can say is disaster recovery. So in the event of any regional disaster or certain redundancy options, it will basically allow you to get protected from these data failures by storing that data into a secondary region. So basically it facilitates the swift recovery and the continuity of your operations. So selecting this appropriate redundancy option, it depends on your organizational specific needs, balancing factors like cost, or data availability requirements or the disaster recovery objectives. So there are so many things or the factors. Based on that, you need to select these one of like the redundancy offering which is best for your project. So the first option is locally redundant storage. So what happens in LRS? So LRS basically replicates your data 3 times within a single data center. So we have this primary region. So in our case, we have selected East US, right? So that is our primary region. In that primary region, we have data center. And in that data center, we have 3 copies of our data stored within the same data center. So that is how this LRS functions. So basically, this LRS safeguards your data or the activity against the hardware failures within the same data center. So it's good option, but the limitation for this storage would be like it does not protect against the data center wide disaster, like maybe for example fire or the flood. Then if that in that case, if that complete data center gets disrupts, then it is of no use. But it like rarely happens or will never occur. But there is a possibility of that occurrence. So for that purpose, LRS would be beneficial. And if your project has very minimal costing, then also you can opt for this LRS option. Then the second option is zone redundant storage. So what happens in this zone redundant storage is ZRS, it replicates your data across the 3 availability zones within a region. So we have our East US primary region, and in that region we have 3 different availability zones, and in that we have 3 different data center. So in LRS, our copy of our 3 copies were in like one data center, but in ZRS, our 3 copies would be into different data centers, but in a same primary region. So that is how this ZRS functions. So the next one would be geo-redundant storage, which is GRS. So in GRS, this GRS basically combines the LRS within the primary region and asynchronously replicates the data to a secondary region. So we can say that data is synchronously replicated 3 times within a single storage cluster in the primary region, and then it was asynchronously replicated to a secondary paired region. So this is our primary region. So in our case, it's East US. So in that data center, it has replicated your data 3 times synchronously, and like despite of this, it also replicates your data into a secondary region 3 times within the same data center. This is how this GRS function. So basically, we can say that it will protect or it will provide you disaster recovery capabilities in case of any regional outage. So like what would be the limitation for this GRS? Then we can say that failover to the secondary region, it requires manual intervention. So without that, your data will be intact in your primary region. So the fourth one is geo zone redundant storage, which is GZRS. So in this GZRS, basically this GZRS integrates with ZRS within the primary region and asynchronously replicates the data to a secondary region. So our data in our primary region East US, our data is synchronously replicated 3 times within 3 different data centers. These are synchronously replicated, and apart from that, it asynchronously replicates your data 3 times into your secondary region. So this is how this GZRS function. So we can say that it will offer you the enhanced disaster recovery and high availability. But the limitation would be for this would be like failure to a secondary region. Again, it will require manual intervention. Apart from that, your your data is already copied three times into three data centers into a primary region. So this is the I can say that this GZRS provides you the maximum protection to your data from all the disasters and recoveries, but it is not cost efficient. It requires a lot of cost. So it completely requires on your project requirement and the budget, which is like available and which is allowed to use. So this is how these are for redundancy storage services functions. Okay, so for the cost effective purpose, I'll just go with the local redundancy storage. Click on next. So here we have this one block, which is hierarchical namespace. So what happens is like this hierarchical namespace, which is nothing but HNS. This is an optional feature in ADLS Gen 2 that basically enhances the way your data is managed within that storage. So it introduces a file system-like structure to the Azure Blob Storage, making it more efficient for the big data analytics, and the higher performance data operations. So this HNS within this storage v2, if we'll just tick mark this option, then it will basically turns this storage into Azure Data Lake Storage Gen 2 account. And unlike traditional flat blob storage, this HNS will allow you to store or organize the data into directories and subdirectories. So for the normal blob storage, you can store your data into one file system. But with this HNS enabled, it will allow you to create the directories. So in this, what will happen? Suppose if I have this one directory, in this directory, I can create subdirectory, subdirectory or sub file storage, and in that I can store my file system. So this is nothing but the hierarchical facility, which it will enable by clicking on this checkbox, and it will convert this storage account into ADLS by offering these services. So with this service, there is one more thing. As like with this service, we know that it makes it easier to manage, structure, or navigate the large data sets, just like this file system. So apart from that, this HNS it also allows the access control lists, which is nothing but ACL. So this ACLs at the directory, we can apply this ACL access control list at the directory or file level, which offers a fine-grained permissions. So it is useful when we have multiple users or the applications that need the access with the different levels of permissions. So we are going to require this ACL feature going forward because we have this Azure Databricks, right? And with Azure Databricks, we need to access this ADLS account. So to access this ADLS account or this ADLS file folders where we have stored our all raw data, so to access that data, Azure Databricks needs particular permissions. So these permissions we can give by using this ACL, which is nothing but access control lists. So this is one of the main feature which we are going to require. And apart from this subfoldering section, that is also important. So these two main features we will get by clicking on this enable hierarchical namespace. So we are going to opt for that. So next, coming here, we have one more feature, which is this access tier. So here we have three options. We have three tiers: hot, cool, and cold. So basically, this Azure Blob Storage offers these three services, right? The main purpose of this is to help you to manage the storage costs based on how frequently you are going to access this data. So we are going to create this Azure ADLS, right? And in that we are going to store our data. So we have this ADLS, in that we are going to pull data and we are going to store our data into directories and subdirectories. So now I need to check like how frequently I am going to access this data. So depending on that, I need to select which access tier is suitable for my storage account creation. The first one is hot tier. So the purpose of this hot tier is that it is designed for the data that is accessed or modified frequently. So if you are going to access the data frequently, then you should opt for this hot tier. And if you talk about the cost structure, then this higher storage costs, it has some higher storage costs, but lower access and transaction fees. So you have this ADLS account. So to store that data into this ADLS, it will require high amount, but to access that data again and again, it will not be that much higher. So this will be the cost structure for hot tier. And the use case we'll see, then it is like useful for the active data sets or the real-time analytics or data staging before processing. So most of the time, hot tier is beneficial. Then the next one is cool. So cool tier is basically suited for the data that is infrequently accessed or modified. So suppose we are not going to use that data frequently, then for that purpose we can opt for this cool tier. So the cost structure is also like it has lower storage, and lower storage cost would be very less with higher access and transactions. So the storing cost is less, but if you want to access it, then that access cost would be higher. So this is how this cold tier will perform. Then we have this third one, which is cold tier. So it is basically ideal for the data that is rarely accessed. So we are not going to use it for with that frequency. So for the rare access, we can opt for this cold tier, but it requires quick retrieval whenever needed. So it is nothing but you are archiving your data. So once you have archived it, you are going to use it rarely whenever required. But when you are going to require it, you need to access it very fast. It should not take much longer time to access your archived data. So for that purpose, you can go for cold tier. So cost structure is even lower storage costs than the cool tier, but with higher access fees. So the storage cost is much lower than the cool one, but the access cost is higher than the cool one. So like use case for this would be like if you want some long-term backups or the data sets and you need to retain that for the compliance, then for that access purpose, you can opt for this cold tier. And there is one more point here, that is retention requirement. So the retention requirement, if we talk about that, then for this retention requirement, for the cold tier, the data should stay in this tier for at least 90 days to avoid early deletion changes. And same retention requirement for the cool tier is that it should remain in this tier for at least 30 days to avoid early deletion charges. So this retention requirement is important for this both cool and cold tier, which is for cool it's 30, for cold it's 90. So this is how this access tier works. So right now we are going to opt for the hot access tier because we are going to access that data frequently. And just click on next. Then these are some private endpoint additional features, routing preference, and just click on next, next, next. We are not going to require this for our ADLS creation. Next. Then it is going to validate all your requirements, and then we'll click on this create, and it will now create our storage account, which is ADLS, into our assigned resource group. So it will take some time. It shows right now that deployment is in progress. So we'll wait for some time till this deployment gets successful. Okay, so now our deployment is completed for ADLS. So now click on go to resource. So this is how our ADLS will look like. So if we talk about the data storage here, then we can see that we have four options here for the data storage. Now we'll see one by one very quickly how it functions. So the blob storage, nothing but containers. We can use this container to store large amount of unstructured data or structured data like CSV files or the documents, image, videos. So in this, we can say that our data is organized into containers, which are like similar to the folders, and these containers holds the files. So we will in the container we will have these containers, and in that we will have folders to store in a mannered way. So we can say that it is ideal for the content storage or and servings or maybe for the backups or the streaming media. So this is useful for that. Then the next one is file shares. So basically it provides you fully managed file shares which are accessible via SMB protocol. So SMB is nothing but server message block. So if we talk about the structure, then these file shares will allow the creation of files of these file shares that can be mounted concurrently by cloud or on-premise deployments. So because of this, we can say that it is suitable for migrating legacy operations to the cloud. So if you want to migrate from the legacy to the cloud, then for that purpose, we can say that file shares are the most useful. Then we have queues, which is nothing but queue storage. So basically, it enables the asynchronous communication between the application components by storing the large number of messages. So the structure of these queues would be like the messages are stored in the queues and that can be accessed from anywhere using any HTTP or HTTPS protocol. So with that, we can access these queues. The use case for this would be like it is useful for building some flexible applications or loading leveling during these high traffic periods. And for example, like decoupling the application components to improve the scalability or resilience. So for that purpose, we can use the queues option. And the last option is tables. So this table storage, it basically provides a NoSQL key value store for this rapid development. So key value pair is important here. So using this key value store, we can have this massive semi-structured data set stored into the tables. And if we talk about the structures, then it stores the data in tables with the schema-less design which allows you for easy adaptation as application needs to evolve. So what would be the use case for this? So we can say that it is appropriate for storing the structured non-relational data such as user information or device data or any other metadata. So these are some of the information for all these four type of storages. Right now for our purpose we are going to opt for the containers. So once you will come here, you can click and create container. So for example, let's say right now we are going to follow this medallion architecture, right? So for that, we are going to have bronze layer, silver layer, and gold layer. So let's just create three containers. So I'll just first container would be silver. Okay, the first would have been like bronze, but it's okay. Bronze, silver, and then the third one would be gold. So right now what we are going to do, we are going to fetch our data from GitHub account. That would be our raw data, right? And we will store that raw data into our bronze layer. So for that we will use Azure Data Factory, and with that data, Azure Data Factory, we will store our data here. Then we will fetch this data into Azure Databricks. We will perform some transformations and then we will store our data into silver layer. So once we are done with that transformations with the Azure Data Factory only, what we will do, we will again fetch this data. We will perform some advanced transformations and then we will store again that business ready data into the gold layer. So this is how we are going to use these three layers here. So now we'll see how we can fetch that data into these different layers. So now first step would be, now we are done with ADLS creation, right? So now we have our ADLS ready with bronze container in that. So now we will create one Azure Data Factory, and now we will pull that data to this bronze layer. So that would be our second step now. So now let's just go and create the Azure Data Factory for the same. Now let's try to create Azure Data Factory. So I'm into my resource group. Again, I'll click on create. Then it will navigate me to the marketplace, and here we will search for Data Factory. Then we will click that, create. So it has assigned respective subscription and resource group here. So now we need to give one name to our data factory. So I'll just give the name as anything like ADF Prime Work. Region, I'll keep it as East US only. Then the version is V2. Next. These like Git configuration, networking, advanced tags, we don't need to configure anything right now. So we'll just check whatever is required, like basics, subscription group, then version, region, and then we will click on create. So it states that now deployment is in progress. So it will take some time to create it. Okay, so now it has been created. So now we will click on go to resource, refresh it. So now see under the resource group, now we can see our Azure Data Lake storage, and along with that we can see our Azure Data Factory too. So now we'll click on that and launch the studio. So this is our Azure Data Factory in which we will try to do this data movement using copy activity. So now if you'll see here on the left hand side, we have tabs of home, then author, monitor, manage, and then learning center. So in learning center, you will get like the videos, tutorials, like you can navigate through that, you can check that, and if you want to learn more, you can all the time you can select for that. Then we have manage tab. Here we can create linked services or the triggers. We can configure the Git. We can create integration runtimes also here under the manage tab. So in monitor tab, if you'll see here, you have all the runs. So if you'll debug anything or if you will run anything, suppose for example, in our case, if you'll run the pipeline, then we can check the status of that pipeline after coming here. So similar goes to the triggers also. If you have set any trigger, you can like keep a watch on that trigger via here. And then we have author tab. So in author tab, we have factory resources. In that we have pipelines. Then right now it is like change data capture is in preview mode. Then we can create data sets, data flow, Power Query. So all these are options available here. So now we are going to create our pipeline under the author tab. So for that, first we will check or first we will see the basics of like how this copy activity functions and what are the requirements, and then we will try to implement that copy activity. This is the overview of Azure Data Factory under which we are going to perform copy activity using this pipeline. So in Azure Data Factory, orchestrating this data movement from the source to destination, it involves several interconnected components that work together to facilitate this efficient data transfer from the source to the destination. So in our case, source is the GitHub account and the destination is the bronze layer into ADLS. This GitHub account is a source. It will basically act as the origin of the data which you want to process. So in our case, it's a repository which contains the data files which we want to pull into our Azure Data Factory. Then we have linked service. So if you see, we have two linked services. One is on the source side and another one is on the sync side. So this linked service, it basically establishes the connection between the ADF and the source. So from the link service which is on the source side, it will establish the connection between GitHub and the Azure Data Factory. This basically provides the Azure Data Factory with necessary credentials. So these credentials are necessary that will get provided with this linked service. And along with the credentials, it will give the connection details to access this data in the GitHub. Then we have dataset. Again, we have two dataset, one on the source side, one on the sink side. So source side dataset, it defines the structure and the location of the data within the GitHub. The purpose, if you see, the purpose is to specify which data in the GitHub account that should be accessed by the ADF, including the file path and the data format. So for that, we have dataset on the source side. Then we have copy activity. So once we have pulled this data from the GitHub using this linked service and dataset, then this copy activity will transfer or will done the data movement from the source to the destination. So now with this dataset, with this copy activity, we have pulled the data. Now we want to store this data to our sink, which is our destination. So for that also we have again dataset at the sink and the linked service at the sink. So this dataset, it will define the structure and the location of the data destination data store. Now this dataset at the sink is responsible for performing the activities which are related to the sink. The first one was responsible for the source. Now this one is responsible for the sink. This goes the same for the linked service also. The linked service on the sink side, it will establish the connection between the Azure Data Factory and your destination data source. So this linked service will serve that purpose for the sink side. And the sink is, it's quite obvious that it's the final destination where the data will get stored after this copy activity. So in our case, it's the folder which we have created for the bronze layer into Azure Data Lake Storage Services. So this is the overview of our Azure Data Factory activity which we are going to perform. So now let's see how we can implement this copy activity into our Azure Data Factory. So for that, now we are clear that we need two linked services, one to establish the connection with the source and another for the destination. And with these two linked services, we need two data sets also. Again, one for the source and one for the sink. So we are pretty much clear that we need two linked services, two data sets, and then the copy activity. And then we will interlink those components, and then we will try to pull this data from the source to sink. So now let's see how we can implement this practically. Now I am into Azure Data Factory, and now we need to create one new pipeline. So for that, I'll come to the author, pipeline, click on these three dots, and then click on the new pipeline. And once you will click on that, you need to give a name for your pipeline. So let's say, suppose I'll just give the name as prime copy data, and then I'll close this. So under this pipeline, we have so many activities like move, transform, synapse, then Azure Data Explorer, then data analytics, iterations, and the conditionals. So there are so many activities you can perform. So right now, first we will start with the basics. So under the move and transform, we have this copy data, and then we will simply pull this copy data onto our screen. So this will be our copy activity. But now we know that for our work, we need two linked services and the two data set to establish the connection with source and the destination. Okay. So first we will create our two linked services. So for that, what we will do, we'll just go to the manage tab. We have linked services, then click new. Here, first linked service, we need to connect with our GitHub account, right? So this is our GitHub account. This is our data. So when you will click on this raw button, then you will get this main data. Okay. And this will be our link from where we need to pull the data. So this data we can see is with HTTPS. So we need to establish a linked service with HTTP. So come here, then we have linked service for HTTP. Click on that, continue. Then you have to give one name. Let's say, suppose I'll give HTTP prime and ls for the linked service. Then you have to, I'll just take auto resolved integration runtime. Then you have to give the best URL. So for the base URL, right now I'll just go with the static pipeline creation and I'll just copy this URL as it is, and then I'll just paste that URL here. So once you will do that, come down and then the authentication type. Authentication type, I'll just select anonymous. And once you are done with inputting the required information, just click on test connection. So it states that our connection is successful. Then I'll just click on create. So this is a linked service which we need for the source side. Now we need another linked service for the destination side. So now again click on new. Here our destination is Azure Data Lake Gen 2. So we need to select Data Lake Storage Gen 2. Click on continue. Then give the dataset, give the linked service name. Here suppose I'll give ADLS Prime LS. Then authentication type, account key is fine. Subscription, I'll select my respective subscription. Then ADLS Prime work. And then just test the connection. Connection is successful. Click on create. Now we are done with two linked services creation. Now again come back to the author tab. Under the author tab, we have this copy activity. So now let's just give proper naming convention for this copy data. Let's say, for example, prime copy data. I'll just give this name. Then come to the source tab. Now here we are done with the two linked services creation. Now we need to create two data sets, one for the source, one for the destination. Source is HTTPS, destination is our ADLS. The source dataset we can create new here. Click on new. Then our source is HTTP. Select that, continue. Then under HTTP, we know that our file is into .csv format. So we'll check that and we'll select delimited text, which is our CSV format. Click on continue. Then you need to give one name for your dataset. Here, for example, I'll give maybe HTTP prime DS for dataset. Then we need to select our linked service, which we have created just now, which is HTTP prime LS. Then relative URL, when we were creating a linked service, we have given base URL as it is because we wanted to create static one, right? So there is no need to give any relative URL here. First row is header, that's true. We don't need to import any schema. Click on none. Okay. So now source dataset is ready. Now go to the sink and again we'll create one sink dataset for our ADLS. So click on new. Our ADLS is Gen 2. So Azure Data Lake Storage Gen 2. Continue. I want to save my file as into CSV format only. So I'll just save the format as CSV. Continue. Then give the name dataset name, maybe ADLS prime dataset. Then we'll select our newly created linked service. Then file path, we need to give our file path because we have three folders created, right? Bronze, silver, and gold. So just come here. We can see those. Right now I just want to save my all raw data into bronze layer. So just select that bronze folder. Click on OK. So once you want to save that data into bronze folder, you need to give a name for that, right? Otherwise, like Azure, any which ways it will pick one by default or system generated file name for that. But if you want to give your own file name, you can give that. For example, I'll here give Prime. What was our original name? Amazon Prime titles. I'll just give this name only. You can give another name also. For the simplicity, I'll just give that name Azure Prime Titles .csv. Import schema none, and then click on OK. So we are done with our data factory interlinked components, two linked services, then two data sets, then copy activity. And now we will see if it is working or not. So for that, first I'll just validate whatever I have done. Okay, so it says that your pipeline has been validated. Then I'll click on debug. So once you will click on debug, it will show that your activity is queued, and then it will change the status to in progress. And once it is done, then it will change to success. It will take some time. Okay, so now it has been succeeded. If you check the output, it states that it has read the data, duration, throughput. Okay, so now it's the time to check if our data has been copied or not. So for that, again, come to your ADLS account, container, bronze. Okay, so now we can see that we have one file here which with .csv format. Let's just check if we are getting expected output or not. Click on that, edit. You are not going to edit anything. It's just that you want to check if you have that output or not. So we can see that we have that output. If I'll click on preview, now we can see that we have show ID, type, title, director. So basically we can say that our Azure Data Factory has successfully transformed our data from the source to Azure Data Lake storage services. So now our first part is done. Now we will try to create Azure Databricks resource. But before that, we'll just come back to this Azure Data Factory. And the main important thing is that we need to publish all of our work. Otherwise, if you'll not publish it, then if once you will close this Azure Data Factory, all of your work will be gone and you will not be able to recover it. So for that, to be on safer side, it's a good practice to always publish whatever you have done. So I'll just click on publish. Now it states that it is deploying our changes which we have created. It will take few seconds to publish it. So now it says that publishing completed. So like again, going forward, if I'll come back to this Azure Data Factory, then my all work will be here and there is no need to rework anything. So now we are done with the Azure Data Factory. Now we will create Azure Databricks. So for that, again, we will come to our resource group and there we will create this Azure Data Factory. Sorry, Databricks. So one is done, then second Data Factory is done. Now third, again, we'll create and go to the marketplace. Then Databricks. Click on this, create Databricks. It is giving me proper subscription under that resource group. If you want to if you want, like, it's a best practice to use the same resource group, so we are going to keep the same resource group. Then we need to assign one workspace name or Databricks name. So what we can do, for example, let's say suppose Azure Data Factory ADB Prime Work. This name is available, so we can opt for this. Region East US, I'll keep the same because that's the nearest one. Pricing tier, we have premium, standard, and the trial. So the best optimum solution is the trial because you'll get 14 days free and it will not charge you for anything for the 14 days. So I'll just select that. Then we have this option of managed resource group. So what is it exactly? So this managed resource group is that when we will create this Azure Databricks workspace, right? Then Azure will automatically generate some managed resource groups. So right now we know that this RG Prime work, which we have created it, right? But apart from that, in the backend, when we are going to create this Databricks, system is going to generate different resource group in the backend. So these are system generated which are created for this Databricks infrastructure resources. So for that, if we'll not give any name here, then it will automatically assign one name which will be created by Azure. But if you want to give your data, like if you want to give that folder name, like your any customized folder name, then you can give that, and then Databricks will store those backend resource groups which are system generated into that folder name. So if you'll not give it, then it is also fine. If you'll give it, then it is also fine. So I'll just give that name and I'll move ahead. For this, I'll give RG, maybe Azure Databricks, system managed system. This seems available. Then next, networking. We don't need to do any changes for the networking, then encryption, security and compliance tags. And we are here with review plus create. Now we will review it and then we will try to create it. So now let's try to understand that it is going to take few seconds to create it. Right now deployment is in progress. Now let's just wait so that Azure will create these resources and backend system generated resource groups and everything. So it will take few seconds for that. Okay, so now our deployment is completed. Click on go to resource. This is our Databricks. We'll click on launch workspace. Select your account. So this is our Databricks platform. So on the left hand side, we'll see we have workspaces, then catalogs, workspace, compute. So we'll need to create one cluster here in compute. Then we have SQL editor, queries. So right now we'll just work on the topics which we want, which we are going to require for this ETL pipeline. And in another video, I'll just cover all these components which are available under this Azure Databricks. So first, now we have our database ready, right? So this is our Databricks, and this is our ADLS account under which we have this bronze layer where we have stored our raw data. So now we need to fetch this bronze layer data in the bronze layer into our Azure Databricks. So how are we going to do that? So to fetch this data from bronze layer, which is into a storage account in Azure, Databricks need to have the right permissions. So first we need to grant those permissions to this Azure Databricks. For that, we need to create an application which is nothing but service application. So once we will create that service application, we will grant the access to that application to read and write the data. And then we will pull this application into our Databricks. So for this application creation, we just need to go to the Microsoft Intra ID. There we will create this service application and then we will grant that application respective rights to read and write that data into Azure Databricks. So in this way, Azure Databricks will be able to read the data from ADLS, and then once it will transform that data, then again it will push that data into the bronze layer, into the silver layer and the gold layer. So for that, we'll go to now Microsoft Intra ID. For that, you need to again come back to your Microsoft Azure account. We'll search for Microsoft Intra ID. So this is our Microsoft Intra ID. Here, just check the option of app registration. It is under manage. Click on app registration, then new registration. Now give your application name here. For example, if I'll give Prime Service Application. You can give any name, whichever you want. Then we are fine with the single tenant and then click on register. So now our application has been registered. Then Afterwards, we need to assign all the essential roles to our application to read and write the data. So now we have created the application. The next step would be to give the essential access for those applications. For that, come to your ADLS account. You have IAM access control here. Click on that. Then you need to add role assignment. Here, search for storage blob data contributors. Select that and then click on next. Then user group service principal, select members. Then search for your application which we created just now, though, and that was prime service application, right? Select that. It will come under selected members. Click on select. And once you will done that, review and assign. So now it will add those respective role assignments here. So what happens, like once it will assign these role assignments, then it will take some time to reflect those accesses into Databricks. So right now, like if you'll all of a sudden go to Databricks and will try to access, and if you'll not be able to access it, then you just don't have to worry. It usually takes some time to access all those roles to that particular application. So take some time and then come back to Databricks and again try to perform those data cleaning and transformation activities. Now the next step is to create a compute. So in Databricks, come to this compute tab, create compute. Policy will be unrestricted. I want it for single node. Runtime would be fine. Terminate after 20 minutes. Node type, I'll just give standard D3V2, which has 14 GB memory and the 4 cores. I'll just create compute. Till our cluster gets created, we will try to club all the information which we are going to require to input when we are connecting Databricks to the ADLS. Okay, so for that, what we are going to require, so come to your app registration and select that app which you have just created under Microsoft Intra ID. And from here, we are going to require this application/client ID and the tenant ID. So now let's try to copy this information somewhere. This would be our client ID. Then we are going to require this tenant ID. And then we are going to require a secret key, which we are going to create right now. So for that, what we need to do, come under this manage tab, then certificates and the secrets, then click on new client secret. Description, if you want to give anything, give it. Add. So now from this client secret, we are going to require this value information. So we'll just copy that, and that will be our secret ID. We have now client, tenant, and then secret ID. So we have these three IDs which we are going to require. Now let's see how we can connect this Databricks to the ADLS Gen 2. So for that, I'm searching like how to connect Databricks to ADLS Gen 2. And here you will get one tutorial which is given by the Microsoft. And then connect ADLS blob. So this is the information which we are going to require here. So with this information, we will just modify our information into here, like storage account, then the client ID, then the secret ID. We will input our those credentials here, and then we will see if we are able to fetch that respective data into Databricks or not. So now let's just check. Okay, so now our cluster is also ready. Come to the workspace. It's always a good practice to create one folder for your work, prime work. And in this, I'll create one Python notebook. So this is our notebook. First, we will connect our notebook to our newly created cluster. It is connected. I'll change the name of this notebook. So I'll give the name as Prime Silver Layer Transformation. You can give it anything. So these are our cells. From here, you can change the default language for your whole notebook. It could be Python, SQL, Scala, or R. Then for that particular cell, if you want to change that language, then you can change it from here. If you want to run that respective cell, you can click on Run Cell. If you want to run all the notebook, then you can click on Run All. So now let's see if we are able to connect Databricks to the ADLS. Now let's try to use this Python code into our Databricks. So I'll just copy this code, paste. I don't need this first line. I'll just remove it. And then we have storage account right here. So we need to give our storage account name wherever we are seeing this storage account section. So our storage account name is ADLS Prime Work. I'll just give that name here. Just keep in mind that you need to change this, or you need to give this storage account name multiple times. Okay, I hope I have given it everywhere. Then the next we need to give application ID. So this is our application ID. Copy, paste. Then we need to give directory ID. So this is our tenant or directory ID, which we are going to give here. And we have this service credential. So this is our secret ID, which we need to give. Okay, so now let's try to run this cell and we'll see if it is working fine or not. Okay, it seems like it is working fine because the cell has run successfully. Then I just need to access the folders, right? So for that, dbls.fs.ls and then inverted commas abfss. Then we need to give our bronze layer information here. Let's come to the container. We'll see if we are getting that information here or not. Container properties. Okay. Let it be we just need to give this bronze container name, right? So abfss double slash, then we have bronze layer into our ADLS account name, which was this ADLS prime work dot dfs dot core dot windows dot net and then slash. Let's see if it is working or not. Okay, so it said that it is able to access this bronze folder from this ADLS framework, and it has one file which has name of Amazon Prime Titles.csv. That means that it is able to fetch that file. So now let's see if we are able to read the data or not. So it's always a good practice. So for data reading or data understanding, first let's just try to import all the PySpark functions and the types. So I usually prefer to import these libraries first so that it will not bother us afterward. So I'll try to import all the functions and then all the types. So this is done. So now we will try to read our data and understand what is exactly going on. So I'll just put a markdown of data understanding. Then now we need to read our data, right? Which is into .csv format. So for that, first we need to create one data frame. So here I'll create data frame as, for example, df underscore silver is equal to, then spark dot read. Okay, it has given me by default code, but in which ways, let's try to understand it. So our data is into .csv format. So spark.read.format and which is into CSV. Then option as header because I need to see my headers also. Otherwise, what will happen? The headers that will come as a first row. So we to avoid that, we need to give options headers as true. And then we need to give infer schema as true to take whatever the schema type it is. So we need that schema type as it is. And then we want to load the data and we need to give that respective path from where we want to fetch that data. So we know that we need this data from bronze layer from ADLS framework, but our file name was something different, right? So this was Amazon Prime titles. So this I need to change with Amazon Prime titles. And then we just need to display our data frame. So this is our data frame dot display. Let's see what happens. Okay, it sets that. Okay, so we have given .csv two times. We'll try it again. Okay, so we can see our data into table, show ID, type, title, director, cast, and so on. So now from here also we can see that this column show ID has a type of string, then type has string, then director has text a string format. So this has happened because we have turned on the infer schema as true. So now let's see, like after reading this data, it is important to check the schema to understand the structure of data. So basically this will help us to identify the data types for each column such as string, integer and float. So if we want to check the schema, then what we can do is like we have df.silver, say df underscore silver, and then we'll just say print schema. So this is our schema. So here we will get the clear picture of like how many column names which we have, how many columns we have, then what are the names of those respective columns, then what is the type of that column. So that complete information which we will get using this dot print schema. So this is like this print schema is the method which prints the schema of the data frame by showing the column names along with their respective data types. Okay. So this is how like we can read the data or understand the data. Then now next what we can do, we can try to clean the data. So the next step would be data cleaning. So in the data cleaning, first we can see how we can handle these missing values. For example, let's try to display this data frame again. See, so here in the rating, we can see that we have so many null values. And along with the rating, if we'll just check the country column, in the country column also we have null values. So for example, suppose if I want to replace the null values from the rating column as unrated, and I want to change the countries which has null values to the unknown. So for that, what we can do, we can say that df underscore silver, which is our data frame, dot na dot fill, and then I need to give two columns, right? So for the two columns, I'll need to give the curly braces, and the first one would be rating. So rating, I would like to change the null values with, for example, unrated. And with this rating column, there is one more column which is country. And country column name, I would like null values, I would like to replace it with unknown. And once we will do this transformation, we will do this data cleaning, then assign that modified data frame to our existing data frame. So that's why I'll do df underscore silver is equal to, and then our condition, and then dot display. So now let's see if it is working or not. Now let's see. Okay, so our country null values are replaced with unknown, and then rating, these are replaced with unrated. So in the same way, like along with this, we can check, like remove the rows or remove the duplicate rows. So for example, suppose if we have multiple records of the same entry, right? And if you would like to drop the duplicates, then what we can do, df underscore, okay, so our df data frame name is df dot silver underscore drop duplicates. And then again, I would like to modify my existing data frame and then display that data frame. So this will remove the duplicates. So now we can see that there are so many null values for the date added or the director. So we need to handle these values, right? So let's try to see if we can fill the null values for other columns also. Country with unknown. Okay, so it has given me the code date added. Maybe date added, I'll give it as zero one 2025. Release year, maybe I'll give it as 2020. Duration is unknown is fine. Description unknown. Listed in unknown is fine. So we'll see how it looks like now. Okay, so we have forgotten some column names, which is director and d- okay, director and the cast maybe. So let's say like now we'll try to delete the values. Like we will try to remove the rows which has any null value in that. So for that, what we can do is like our data frame and then dot drop na, and in that I'll give the string as any. So any means that it will remove the rows if that row contains any null values in any column. So now let's see how it functions. Okay, it seems like we have fair enough data. Okay, fine. Then, for example, if we want to rename the column name for the better readability, okay? So let's say suppose we have this column name as title. So I would like to change it as content title. So what I can do here is df underscore silver dot. Then I'll use the function which is with column renamed. And with column renamed, I would like to give existing column name, which is title. And then I would like to change that name to content title. And then I would like to display this new modified data frame. Let's see. Okay, it has been changed successfully. Now let's say suppose I would like to do one data transformation here. So for this, I'll use this country column. So for this transformation, what I'll do is like if the column entry is in this country column is any particular country, then I'll assign the value as 1. Otherwise, if that country value is unknown, then I would like to assign that value as 0 into our newly created column. So for that, what we can do? So for this, we have our data frame, and we will use with column function for this. And then we need to assign what should be our new column name. So maybe I'll give the name as is country. And then I need to assign that condition which we just spoke right now. So when our column country is equal to unknown, then I would like to assign the value as 0. Otherwise, I would like to assign the value as 1. And I want to add this new column into my existing data frame only. So for that, I'll just assign this condition to my existing data frame, and then we'll just display that new data frame. Okay, what is it saying? So we have given column 2 times. Okay, now we'll see. We have its country column. If we have name as unknown, then it is giving us the value 0. Otherwise, it is giving us the value as 1. So now let's say suppose I have transformed our data, and now I would like to store that data into Parquet format and into our silver layer. So basically what we need to do is like here our data frame is df underscore silver, then we need to write our data frame in the format of, so right now I just want this into a Parquet format. Then mode, I would like to give the mode as append. And then I would like to save this data, but before save, I need to give file path here. So option, then path would be comma, and then our path would be abfss, and now it should be into silver layer. So I'll just change this to silver, and then what should be the file name? I would like to give this file name, and I'll just add silver into it. Amazon Prime titles, maybe silver layer. Okay, CSV. Then this would be our path. And once we are done with that path, just save. Okay, so now we are using append mode. So we have four types of nodes. So one is append. So with append, what will happen? So with append, let's say suppose this is our ADLS and this is our silver layer, okay? And we have our files already stored here. And now we are trying to store this Amazon Prime title silver file here. So now let's say suppose if we already have the file with the same name into our silver layer, then with the append, it will just add that new file below that file. So it will not erase that already existing file. It will just keep adding the new files into that silver layer using this append mode. So this is about the append mode. The next mode is overwrite mode. So in overwrite mode, what happens is like if we have already existing file into our silver layer and we are now trying to store this new file with the same name, then what this overwrite mode will do, this overwrite mode, it will replace this existing file with this new file. So that previous file will be gone. You will not be able to recover it, and then you will just get the new file which will get stored here. So this is how this overwrite mode works. Then we have error mode and ignore mode. So with the error mode, again, what happens? If this write mode will try to store this same file into our ADLS and it sees that, okay, we have already existing file with the same name. Then with the error mode, what it will do, it will not save your new file into the ADLS folder and it will throw you some error setting like maybe you already have file there or something. So it will basically throw the error and it will not save your new work into the existing ADLS work. So this is how this error mode will function. And now the fourth one is ignore. So for ignore, what happens is like, again, this is our ADLS. We have this file already present here and we are trying to save this file here. It will simply check and it will say that, okay, you have already one file over there with the same name, and it will not save your file there, but also it will not give you any kind of error. So it will simply ignore it and it will not save your work at that time and also will not give you any kind of error. So this is how this four mode works. So now we are just trying to use this append mode and we'll try to save this information, and format we would like to be into the Parquet format. Now, to save this or write this format into our silver layer, we are going to use this Parquet file format. So now let's try to understand a little bit more about this Parquet format. So Parquet format is nothing but a columnar storage file format. This is columnar storage file format, which is basically designed for the use with big data processing frameworks like Apache Spark or the Hadoop. So we can say that it's an open source format, and that has become one of the most commonly used file format for the big data due to its efficient storage and fast performance. So these main feature about this. So like if we'll talk about the main key feature about this format, then first one we can say is columnar storage. This columnar storage is this Parquet stores the data into columnar format, meaning that data is stored column by column rather than storing it by row. So what it will do is this will allow you for the better compression and more efficient querying because you can read only the columns which you need. So for example, here, if you need to read just the year column and you just don't want to fetch any other kind of information, I just want analysis of the year column. So for this year column, what it will do? It will just, this Spark will only load the year column into the memory and it will not load the entire rows. So this is what a columnar storage is. Then the next key feature would be compression. So this is the second most important feature. So Parquet supports the multiple compression algorithms. For example, one is Snappy or gzip or LZO. So these are some algorithms which help to reduce the storage space. So this columnar format and the compression, it can significantly reduce the amount of disk space required to store the data. So this is the second most important, which is compression. And the third one I'll say is schema evaluation. So with this schema evaluation, what happens is that Parquet allows this schema evaluation so that like you can change the schema of your data over the time period. Like while you are using or while you are able to read the older data also with the original schema. So what do you mean by changing the schema? So right now we just saw that we have added one new column, right, which is its country. So if you'll see in the source file, that column was not there. But like after the changes, we have this one newly added column, right? That means that we have changed the schema of our data. So with this, no, if suppose if normally if we'll try to write this data into the silver layer, it will throw us the error because the schema of the source and schema of the destination is not same. But with Parquet, it gives that facility or the flexibility of schema evolution. That means that if your data has been changed or if your schema has been changed, then also it will allow you to store that data into our silver layer. So these are some important features of the Parquet. That's why we usually prefer Parquet format or the Delta format. So now let's see if it is allowing us to store the data or not. Okay, it has been successful. Now let's come to our silver layer. Okay, now we can see we have one folder here. And in that folder, we can see that we have our Parquet file. So this will not be visible. Okay. So now we can see that our data has been loaded successfully into our silver layer. That means our second step is done. Now our third step would be, now we will fetch this data from this silver layer, whichever data is here, into Databricks. And we will try to perform some advanced changes on that so that our data will be business ready data, and then we will push that data into the gold layer or the gold folder which we have created here in the ADLS framework, which is this folder, gold folder. So we will try to see after after the changes if we are able to load our business ready data into this gold folder or not. Now let's see how we can move ahead. So for that, I would like to create one new notebook and just create the duplicate of this. Go to the workspace, and then I'll create one new notebook for our gold layer transformations, and I'll connect my cluster for the same. Again, the same procedure we need to do to fetch the data. So I'll just copy paste whatever the steps which we have created. So this first one was that Python code with different directory IDs, secret keys and all. Then we'll see if our, instead of bronze, now we need to see if our silver folder is ready or not. We can see that we have one folder here. And then we will try to import these libraries again. Then we will read our data again. So now I'll have df underscore gold framework spark.read.format. Now our format is Parquet. Header true, env schema true, and now we don't have data into bronze, we have into silver layer. And in silver layer, we need to assign this folder name also, right? Now let's see. Okay, so we have done one mistake. Df, it should be df underscore gold. See, now we are able to fetch this new data which we stored into our silver layer. We can see our new column also. That means that our schema evolution was successful. Then we have changed the title to content title. It is also true. It is also getting displayed. We don't have any null value. Okay, that means that our second step that has worked properly. Now we'll see how we can apply some advanced transformations on this gold layer, and we'll try to again load this data into the gold layer. Now let's say suppose I want to do some advanced transformations. So for example, in the date added column, I would like to just check the date formats of that respective column. And if it is not already into the proper date type, then I would like to convert that format into a proper format, which is MMDDYY. Okay. So for that, what we can do, so we will have our data frame. So df underscore gold. Then we will use with column function. And with column function, we would like to use with date added column, comma, and then we need to write our condition. So to date again, our data is into gold layer. Here we will again use the column name, which is date added, comma, and it should be into mmddyyy format. And then, okay, so I think so we just don't need to fetch only year here. Or maybe we can also fetch or also extract the year, only year for the business analysis. So for that also what we can do, df gold is equal to again our data frame dot with column, and we would like to create one new column which is year added, and then year df gold data frame, and into that our respective column name. So now we'll just try to see if it is working or not. So just display it. Okay, so now let's see. Okay, so date added column has been changed successfully. And then it has also given us the year added column, which is like only year, which is getting displayed from the date added column. Okay, so now we can see that this is working fine. Now let's see, or let's try to implement one more transformation and let's see if it is working or not. So for this, what we will do, we will use this listed in column. Where is it? Okay. So we can see that we have so many entries here, like animation, comma kids, comedy, comma kids. So let's see if we can split this one column into two different columns. So for that, we will use split function. So let's see and let's implement that. Our data frame, then with column, and we want to use with column and we would like to create a new column name, which is, for example, category 1. And in this, we will try to use split function. So split, and then what you need to split. So I would like to split listed in column by the comma, and I would like to get 0th index of the same. So similarly, I'll just copy paste it, and then I would like to create another column as category 2 and split the listed in column, and I would like to take the first index of the listed in column. Let's see what is it showing. Okay. And now we'll see or we'll try to display our modified data frame. So let's see. Okay, so now we can see that we have one category 1 and category 2 separated. Okay, so now we have splitted our column into two categories. Then we can check if we have any missing values in any category. Or now we can see that we have category 1, but for the category 2, we have so many null values, right? So we would like to replace these null values with, for example, unknown text. Now we will try to replace all the null values from the category 2 with the unknown text. For that, what we will do, df underscore gold is our data frame. So in this data frame with column, we would like to check category 2 column name when this df gold category 2 is null, then comma, replace it with unknown text. Otherwise, let's try to give, okay, so otherwise, whatever is the existing category, keep it as it is. Let's see, hopefully it will work. Okay, now we can see that whatever null values were there, those are replaced with the unknown text in the category 2. So this is how you can perform some kind of advanced transformations. I'll not be able to cover all those transformations, but these are few which I have done so that you will understand what we need to do exactly. So now we need to save this data into delta format into our gold layer. Okay, so for that, what we will do, we will again use the same technique to write our data into gold layer. Now we will try to save our data into delta format. So I'll just change the format as delta. Then mode, I'll keep it as append. And now our path will be, instead of silver, it will be gold layer. And here also I'll change the folder name as gold. And now we will try to save this data. Okay, so it should be df underscore gold. So it is now successful. Now let's cross verify it. So this is our gold layer, and in that we have now one new folder, and in this we have our file path here along with file saved here along with delta logs which are stored just above that delta format file. So the question is like, why do we need to use this delta format, right? So for this data format, I can say that there are so many key features for this data format or the advantages. So the first advantage, I can say that this data format supports ACID transaction. So ACID transaction is nothing but atomicity, consistency, isolation, and durability transaction, which basically ensures that all the read and write operations are done in a reliable and consistent manner. So this is especially useful for the big data environments where like we have many users and the processes may be like accessing or modifying the same data concurrently. So for that, this atomicity ensures that the set of operations, like for example write, is treated as a single unit of work, either like fully completed or not executed at all. So such kind of atomicity, then consistency, then isolation, and the durability, this is supported by this delta log or delta format. Then the next one, I would say time travel. I'll just cover theoretical part of the same. In the next video, I'll be trying to covering Azure Databricks completely. So in that, I'll show hands-on for these activities like time traveling and versioning, schema evolution. So I'll try to perform those practical sessions over there. So now it's time travel. So it is nothing but versioning. This Delta Lake provides the ability to travel back in the time by querying the older version of the data. So it supports the time travel to access the historical versions of the data, which is especially useful for the auditing or the debugging or recovering for the errors from the errors. So for example, you are working on one data set and by mistake you have deleted the data, or by mistake you have deleted some rows in that data. So now you need to fetch, or you need to recover the past version of that data where all of that data was present and it was not deleted. So for that purpose, we can use this time travel, and with that time travel, we can recover our older version and we can restore that older version so that we can perform our next activities, and we can this mistake which we have done by deleting some rows, it will not affect the previous version and we will be able to proceed ahead very successfully. For that, we use time travel, and then again, it also supports the schema evolution. Like as I have already told about the Parquet format, it's the same way it also supports the schema evolution, so that like if the schema of the data has been changed into the transformations and is different from the source, then it will not give you any error while storing that data back to the sink. So this is schema evaluation, and it also supports the large scale data processing, and it has data lineage and auditability also, because delta tables automatically track the data lineage. So this, what is this data lineage? So with this data lineage, it makes us easier to trace the flow of the data from the source to destination. So this basically ensures that our data has transparency or regularity compliance and also the effective troubleshooting. So for these purposes, we use delta format, and in that we also has this delta log transaction files. If we talk about this delta log in brief, so we can say that this delta log is essential. This is an essential component in Delta Lake, which basically tracks all the changes that are made into this data table, which enables this ACID transactions, version control, and the schema evolution. So this delta log basically gets stored into this folder underscore delta underscore log, and it consists of sequential JSON files that basically records the metadata of each of the transaction. For example, it could be maybe insert, update, or the delete. So such kind of transactions get stored into this JSON file, and it these files are named incrementally, starting from like if it's 000000. Then if we do some changes and then store it, then it will be 01, 02, 03. So it will be into this incremental mode. So this is how this delta log functions. So this is just a brief. We'll try to cover this into any another video which I'll create on the Azure Databricks. So now let's move ahead and see how we can connect our Databricks to the Power BI. Okay, so now we know that we have pushed our data into gold layer, right? But what if suppose I would like to create one external table or delta table on the top of this data? So why is it useful to create the external table? Let's try to understand. Suppose this is our silver layer and this is our gold layer. And we know that we were earlier having this data into silver layer, right? Then we fetched this data and transformed that data and then pushed that data into gold layer. So now we have our files into gold layer. And suppose for by mistake I have used drop command, okay? So in this case, what drop command will do, it will delete the table and data which is already present into gold layer, and our all data will get deleted and we won't be having access to our data after this drop command, right? So for that sake, what we can do, just to avoid that, suppose this is our gold layer, and we will create one external table on the top of this gold layer. So this is our external table. So we have all the data into these files into gold layer, and this is our external table. So in this case, if we will use this drop command, then this drop command will only delete this external table and not the data which is already present into gold layer. This is how our data will be kept safe, and we will not be there will not be no there will not be any kind of loss onto our original data which is saved into this gold layer. So this is where this external table concept comes in. So let's try to create one external table on the top of this data. So for that, what we can do, for that we will just create one database into a SQL language. So for that sake, select SQL language from here, and the code is very simple like the SQL. Create database and the database name. So in this case, my database name would be gold layer. Now let's try to execute this command. Okay, so it says that it is already present. So now let me just drop this database first. Okay, so now we will create our database again with the name gold layer. Okay, so this is our new gold layer. And now we will save our data into delta format as a table in the gold layer. Okay, so for that, what we will do, the syntax will be same. We will write it in Python. This is our data frame name. Write format would be delta. Mode, I would like to keep it as append. Then the path. We need to give the path of our gold layer. Okay, so this is my path. Let's say suppose in this path I would like to create one file folder inside that. So maybe my folder name would be prime gold, and then I would like to save this as a table. So for that, save as table, then I'll give the gold layer, which is our database name, and dot. Then I would like to give the table name as maybe prime gold. And now it should be in inverted commas. Okay, so now we will try to run this cell. Okay, it has been run successfully. Now let's see. Now if we'll come to our gold layer, then we can see that we have a new folder of name prime gold. And in that prime gold, we have this Parquet file on the top of this delta log. So now we know that we have saved our format as a delta, right? So delta format is nothing but Parquet file, the Parquet file format, and on the top of that we have this delta log. So this create our delta format overall. So if we can see here, we have this Parquet file, right? We have already discussed our uh, compressive algorithm, which is snappy, and our format is into dot Parquet. And on the top of that, it has created delta log. So overall, it means that this is a delta format in which we have saved our data. So we can see that this is how we can save our data as a table. Now let's say suppose I want to check it. Like I would like to create one. I would like to use SQL command on this. So now let's just check, and if we'll see that if we are able to access that table or not. So for that, what we will do, select star from. Then our database name was gold layer, and in that gold layer, we have used prime gold. And now let's try to run this cell. Okay, so now we can see that that's like that format, that table which we have saved it, right, with under the database gold layer with the name prime gold. We are able to access that table successfully. So that you can use this SQL command or SQL language also to work on that table. So this is how we can use this. Now the next step would be how we can connect this Databricks file to the Power BI, right? For that, what we can do, come to the marketplace. In the marketplace, search for our Power BI. and then just click on connect. And it will ask you to download the file. But before that, we need to select the compute because this has automatically connected to the serverless starter warehouse, but our files are into another cluster or compute, right? So select your proper compute or cluster and then just download the connection file. So once you have downloaded it, just click on that file and try to open it. So now in this case, what happened is I was already having Power BI downloaded on my laptop. So for that, what you need to do, you just go to the Google and just write it as download Power BI desktop, and you will get the link very first and just download and install that Power BI desktop on your laptop or a desktop. So now in this case, what happened? It has directly connected to my Power BI because I already connected my Power BI to the same Databricks file. And if you'll come under this Hive meta store, then we can see that this database which we have created is here, gold layer, and under that we have table as prime gold. But what happens is that before this, it will ask you to connect to your respective Databricks, right? So for that, what it will give? So it will give you one pop-up. In that, you need to select access key from the left hand side. And once you will select this personal access key, then it will ask you to enter your access key. So you just need to enter your access key and then you just need to click on connect. So where you will get this access key, right? So for that, get that personal access key, just come back to your Databricks, select your account, go to the settings, and under the settings, you will get the option as user and then the developer. And here you just need to click on this manage access token. And then just generate one new token. Click on generate and it will give you one token. You just have to copy this token because it once you will close it, you will not be able to get that access again. Click on done. Then come back to the Power BI. Where is it? Okay. I'll just again reopen that. Okay, so here you will get that pop-up. And in that pop-up, once you will get that pop-up, just click on personal access key. And whichever key we have copied, right, just paste that key here and click on connect button. So once you will click on connect button, then you will get this navigator. And under this navigator, if you'll see under the Hive meta store, we can see that we have this database which we have created, gold layer, and under that we have this table. So just if I'll click on this and just click on load. It just will create a connection. It will take some time to load the data. Okay, so now we can see that we have our prime gold data here and all the columns which are present here. Now you can create dashboards here. You can create multiple charts like bar chart, pie chart, whichever is suitable for your information. So you can fetch that. You can create charts and you can fetch respective column into X and Y axis, and you can add legions, small multiples. So all the required information you can add it, and you can create 4 to 5 charts which are most useful for the business because they are from non-technical background, and when they will see your report of the dashboard, they need to able to, or they should be able to grasp what is exactly going on despite of they are from non-technical background. So it is very important to know that which fields are important to display and which dash or which charts are needed to display or show it to the business. So this is how you can create report on this Power BI desktop. and this is what we have created till now. So this, I think that this is it. This is how we have created ETL pipeline from starting from source to destination, which was our GitHub account, to connect it to the Power BI with the business ready data. For that, we have used Azure Data Factory to ingest the data. Then we have utilized Databricks to create other Medallion architecture, which were like silver and the gold. And we saw like how we can create this Databricks to the ADLS account, and then how we can fetch that data, how we can transform that data, and how we can again pull that data to different layers into ADLS Gen 2. And once we are done with our work, how we can create and how we can connect our Databricks to the Power BI. So this is how end-to-end pipeline works. So if you have found this video very helpful, then please don't forget to like the video and subscribe for the more content. And also let me know in the comments if you have any questions and if you want more such kind of videos. So in the next video, I'll try to cover the Azure Databricks in detail with new concepts which are already there, like Delta Lake and so on. So thank you so much for watching this video, and till then keep crunching the data.